Okay, guys, so for 5.5 notes, we are graphing radical functions. The first one we are going to study is the square root function. Okay, so the parent function is y equals square root of x. HK form. Remember, we've studied HK form before. So this is going to be f of x equals a is in the front times the square root. As you can see here, it's the square root of x minus 8. Now, outside of the square root is plus k. So do you guys remember we study quadratic? So it looks like this, right? A times the quantity of x minus h, and then close it square plus k. We have study absolute value, which looks like this, all HK form. We have study rational functions, which is x minus h in the bottom with the a on the numerator and then plus k in the back. We have study linear, which is, for this one, we're going to call it point slope. So y minus k equals, your a is really your slope, x minus h, okay? Then, if you guys remember, we also study cubic function, x minus h to the third, and then plus k. I'm trying to think what else we have studied. It'll come back to me if I miss some. So we have a line, a degree of 2, which is a quadratic, a v shape, a cubic function, and a rational function. So now we are going to look at the radical form and what that would look like. Okay, so graph the parent function, which is y equals square root of x, then find all of the characteristics in the box, okay? Let's start with kind of plugging some points in. Remember, if it's a square root, we can't have negative under the square root symbol, so we will start with 0. Square root of 0 is 0. Next number, a nice square number, is 1. Square root of 1 is 1. Technically, yes, we can pick 2 and 3, but those are not nice numbers. So we're going to go with 4 because square root of 4, guys, is going to be 2. We're going to pick 2 more values. I want to round out 5 of them, okay? The next nice number, yes, we can pick 5, 6, 7, and 8, but those are really not nice square numbers, so we want to have nice square numbers. Square root of 9, guys, is going to be 3, and the last one we are going to use is 16 because square root of 16 is a nice value of 4. So let's plot. When x is 0, y is 0. When x is 1, y is 1. When x is 4, y is 2. When x is 9, I'm going to go up. I can go off the grid. I'm going to go 11, 12, 13, 14, 15, 16, and then I'm going to give 4. Okay. Don't be nervous or shy about going off the grid, just like this. Okay. If you ever miss your dots, sometimes I do because I make them too big, then just go off the grid. So what I call this, I call it the eyebrow curve, right? Because you have 2 eyebrows, the hair right there, and then you have your eyes. So I call it the eyebrow curve because it looks more like an eyebrow, like that. Okay. So h and k. It's a parent function, so we don't have any h and we don't have any k. So this is going to be 0, 0. X-intercept, it crosses the x-intercept at 0, 0 because it is the parent function. We're going to go over here and said, hey, do we have an axis of symmetry? Remember, an axis of symmetry, if it divides the graph perfectly in half, such as the quadratic or a V shape. So for this one, we're going to say NA. Y-intercept happens to be the same exact dot as the x-intercept, so 0, 0. This is a closed dot, so x is going to be bigger than or equal to 0 for your domain, or I'm going to use bracket 0 to infinity. The range is the same thing, right? It goes up forever, so y is bigger than or equal to 0, or write this answer as well, 0 to infinity. It's increasing the entire time because as you're going, if you're walking from left to right, okay, remember we're taking a little walk, y is getting higher and higher. So decreasing is NA. It's increasing, and because we have a closed dot here at 0, 0, it's going to go 0 to infinity. Rate of change is going to be varies because it's not a line. And it is a one-to-one function, guys, because it is a function, but it's also every y can only have one x. That means it passes your horizontal line test, okay? So yes, this is a 1-to-1. We have a minimum value. A minimum value is the lowest value, and we only use the y value. In this case, y is 0. Maximum value is none, because this arrow right here, guys, it goes on forever and upward. So NA for maximum. We do not have any horizontal asymptote for our square root function. Remember when we were studying the rational function, we had the horizontal and vertical asymptote. So let's recap on the transformation refresher here. If A is negative, we can state that it has a reflection over the x-axis, or we call it a vertical reflection. Now, if A, the absolute value, is less than 1, for example, if A is a half or A is a negative 1/3, absolute value of negative 1/3 is still less than 1. So we call this a vertical compression of whatever that A value is, okay? If A is bigger than 1, in this case, absolute value of A. So for example, if A is 7, or if A is -2, absolute value of -2, guys, is still 2, which is still bigger than 1. So the negative itself, students, is going to take care of the reflection over here. So the vertical stretch, if A is, absolute value of A is bigger than 1, is a vertical stretch over that absolute value, okay? Then we have H, a positive H, guys, a positive H. This is going to go right H units, whatever H units may be. A negative H is going to go left H units. Now K, positive K, this is going to tell us that we're going to go up K units. And then a negative K, this is going to tell us go down K units. And if you guys remember, we had these steps here before. Steps to graph any function in HK form, okay? Number 1, guys, we are going to identify the parent. Super important to know which parent function belong to which, okay? Then we are going to make a table for the parent function. Okay. When you make a table, pick x values that make sense. So if you have a square root, we are not going to pick any negative values, right? Now, if you have a cube root, then we can pick some negative and some positive. If you have a line, then you can pick any value of x you want. If you have a quadratic, then again, you can pick any x you want. So you kind of have to think about the function a little bit. Then make a list of what A value is, H value, and K. That will allow us, guys, to list the transformation, okay? Then we need to make a new table for the transformation, where we add or subtract the H to your X, and then take the A value, multiply it to Y, and then whatever the K is, we add it or subtract that to Y.